Hello everyone. My name is Akanksha. I did my PhD from IIT Bombay in mathematics and currently I'm serving as an assistant professor at Manipal Institute of Technology. So today's topic is combination. It is a very important topic in mathematics. This is a very useful topic also in terms of applications. So in today's video, we will first see what is mean by combination. What is combination? And then we will start solving some problems on combination. Today's video is very basic and for intermediate level of questions we are going to cover in our next video. So let's start. So first thing is, what is a combination? So as you can see, a combination is a way of selecting objects from a group where the order does not matter. So what is combination? Combination is a way of selecting certain number of objects from a group. So suppose you have a group of balls, means let's say you have a group of people and you want to select only two people. So if that kind of scenario is there, that time you have to use combination. So combination is a way of selecting objects from a group. And in combination, order does not matter. What does that mean? Order does not matter. Here is a example. So suppose you have three fruits, okay? Apple, banana, and cherry. Now, if you need to pick only two fruits, means let's say somebody asks you that apple, banana, and cherry, just take two fruits. So, what are the possible combinations you have, or in how many ways you can pick two fruits? So, possible options you have apple and banana, apple with cherry, banana with cherry. So in this case, whether you are selecting apple first or banana first, it does not matter, right? Because ultimately you are picking two fruits, apple and banana. So that is what it means, that order does not matter. So here apple and banana is same as banana and apple. So in how many ways you can select two fruits out of three is three ways. Apple with banana, apple with cherry, and banana with cherry. Now the thing is, if you have a group of very small objects, like here you just had three fruits, then it is fine. Now suppose you have a group of 100 fruits and somebody asks you to choose 10 fruits. So there will be a very huge number of combinations. Now you cannot keep on arranging the fruits and then counting it would be very tedious. So if you have a small group of objects like 3, 4, 10, and you want to pick a certain number of objects, then it is fine, you can count it easily by grouping that, like in this example, apple, banana, apple, cherry, and banana, cherry. But if you want to group, if you want to select a higher number of objects from a huge group, then it would be a problem. So in that case, how will you calculate it? So here is the formula. Formula for combination. The number of ways to select R objects from N objects. So here always remember N is greater equal R. So if you want to select R objects from N objects, it is given by this formula. We call it N choose, sometimes we call it N choose R. NCR means N choose R, and we write it as NCR. And the formula is factorial N upon factorial R upon N minus R factorial. Okay, this is the formula. But what is N factorial? N factorial is nothing but N into N minus 1 into N minus 2 into up till 1. For example, what is factorial 3? Factorial 3 would be 3 into 2 into 1. Means start from 3 and go till 1. What it would be? It would be 3 into 2 into 1. That will give you 6. Similarly, let's say somebody asks you to calculate factorial 4. So what is factorial 4? Factorial 4 is 4 into 3 into 2 into 1. That will equal to 4 into 3 is 12 into 2 into 1 is 2, and that will give you 24. Is that clear? And similarly, factorial 1 is 1 and factorial 0 is also 1. This you have to remember. Factorial 0 is 1. Now, first thing, before going into the problems on combination, first thing you have to understand this formula. Let's see how to calculate this NCR. So we will start from there. Example calculation. So find 5C2. What does it mean? It means you are selecting 2 objects from 5. So total you have 5 objects. You want to select only 2. In how many ways you can do it? 5C2. And what is the formula? Remember NCR. In this case, N is equal to 5 and R is equal to 2, right? So N 5C2 is equal to factorial N upon factorial R upon N minus R factorial. Now substitute the values. N is 5 factorial upon R is 2 factorial. 5 minus 2 is 3 factorial. So it will be 5 factorial upon 2 factorial and 3 factorial. Now you already know what is 5 factorial. 5 factorial is 5 into 4 into 3 into 2 into 1, right? Upon, what is 2 factorial? It is 2 into 1 into, okay, this is one thing, 3 into 2 into 1, right? That is 3 factorial. Now you cancel out. So you can see that 3 into 2 into 1 is sitting in the numerator as well as in the denominator. So you can easily cut this term by this term, right? These both terms you can cancel out. So you will be left with 5 into 4 upon 2 into 1. So 5 into 4 means you can easily say this as 5 into 2 because 2 and 4 will give you 2 over there. So you will have 10. So 5C2 is, so 5C2 is equal to 10. So what does it mean in English? It means there are 10 ways to choose 2 objects from 5. So if you have total 5 objects and if somebody asks you to pick 2 from 5, you have 10 ways. Is that clear? Yes, next problem. Next problem is, so basic questions on combination. So first thing you need to do is understanding the formula. So here you need to find 4C2. So here in this case, what is N? N is 4, R is 2. As I told you, N will always be greater equal to, N is always be greater equal, let me erase this, greater equal R. So it is intuitive now. So in a group of 5 people, nobody will ask you to pick 6 objects, right? So if you have a group of 5 people, maximum to maximum, you can select all of them, right? So because combination is nothing but grouping number of objects from a group. So from a group, so in that group, the number of objects should be greater than the number of object you want to select. Okay, so choosing 2 objects from 4. So apply the formula. Formula is n factorial upon r factorial, but that is 2, right? That is 2 factorial and 4 minus r. So it will give you 4 factorial upon 2 factorial into 2 factorial. So now 4 factorial means 4 into 3 into, can I write it as factorial 2? Same thing, no? So 4 into 3 into 2 into 1. 2 into 1 is nothing but factorial 2 upon 2 into 1 into factorial 2. Now you can see that this term is sitting in the denominator as well as in the numerator. So you can cancel it out and you will be left with 4 into 3 upon 2 into 1. So this 2 and this 4. So you know that 4 is a divisible of 2. So you will have 4 into, you will have 2 into 3. That means 6. So total number of ways is 6. So picking or selecting, let me write it down. Selecting 2 objects, right? From 4 in 6 number of ways. So you can select 2 objects from 4 in 6 number of ways. Now find 6C3, choosing 3 objects from 6. So you know the formula. 6C3 is same as factorial n is 6 over here, right? Factorial 6 upon factorial r into 6 minus 3 factorial, right? What is 6 factorial? 6 factorial is 6 into 5 into 4 into 3 into 2 into 1, right? Divided by 3 factorial, that is 3 into 2 into 1 into 3, 6 minus 3 is again 3 into 3 factorial. Fine. Can I write this numerator as 6 into 5 into 4 into factorial 3? Because factorial 3 is nothing but 3, 2 into 1, right? That I am writing as factorial 3. Now, this thing is divided by 3 into 2 into 1 is same into factorial 3. But here you can see that this thing and this thing are sitting in the numerator as well as in the denominator. So, we can easily write it as 6 into 5 into 4, right? Divided by 3 into 2 is 6, right? And this 6 and 6 will get cancelled. So you will have 5 into 4. That means 20, right? So number of ways you can pick. So 6, choosing 3 objects from 6 is 20. So you will have 20 combinations. Okay. Next problem. Again, this I think you can do easily. 5C1. So n is 5, r is 1. It is factorial 5 upon factorial r, that is factorial 1. 5 minus 1 factorial. And that is same as 5 into 4 factorial, right? You can write it in this way, 5 into 4 factorial, or shall I write it again so that it will be clear? So 5 factorial by formula is 5 into 4 into 3 into 2 into 1, right? That is 5 factorial. 1 factorial is 1 into 5 minus 1 is 4 factorial, right? But can I write this thing 4 into 3 into 2 into 1 as 5 into 4 factorial? Can I do this? Right? No? 1 into 4 factorial. Now you can see that this thing and this thing both are the same, sitting in the numerator as well as in the denominator. You can easily cancel them out. So you have 5 ways. So you can pick one object out of 5 from a group of 5 in 5 ways. Right? That is pretty intuitive. Suppose you have 5 fruits: banana, apple, grape, cherry, and pear. So in how many ways? So you have 5 options, right? If you want to pick one, you have 5 options. You can pick apple, you can pick banana, you can pick grape, you can pick pear, or next one was okay, whatever it was. Okay, so you have 5 ways picking one fruit out of 5. So choosing one object from 5, you have 5 possible ways. Next problem, choosing 5 objects from 7. So it is, you need to calculate. So here you need to calculate 7C5. Again, n is bigger than r as usual. So 7 factorial means n factorial divided by r factorial into 7 minus 5 factorial. So that is equal to, can I write? So that is same as 7 factorial upon 5 factorial into 2 factorial, right? So you can see that 5 factorial is sitting in the denominator. So whatever is the bigger factorial, try to split your numerator into some numbers and that factorial. So what I mean is 7 factorial, you already know the formula. That is 7 into 6 into 5, 4, 3, 2, 1. But 5, 4, 3, 2, 1 is same as 5 factorial, isn't it? Divided by 5 factorial into 2 factorial. And now you can see that this 5 factorial is sitting in the numerator as well as in the denominator. You can easily cancel that out. Here you have 7 into 6 upon 2 factorial means 2 into 1. And 2 and 6. 6 will get cancelled by 2 and you will left with 3. So the final answer would be 7 into 3. And that is equal to 21. Is that fine? So basically 7C5 is equal to 21. Okay. So that is how you have to calculate. Now some application based questions. So suppose, as you can read over here, a team of 5 players need to select 2 captains. So in how many ways can they be selected? Try to understand the problem. So again, you need to find out in how many ways they can be selected. Solution. A team of 5 players needs to select 5 captains. So you have 5 players and you need to select 2 captains, right? So you need to select 2 players out of 5 players. That is what it means. Because a team of 5 players, you have a group of 5 players, and out of those 5 players, you need to select 2 captains. So those 2 captains could be anything. Those 2 captains can be anything. Means any 2 players you can make captains. So basically, in how many ways they can be selected? 5C 2 ways. And we have already calculated it. 5C2, right? We have already calculated, but we'll see this again. Factorial 5 divided by r, factorial r, and 5 minus 2 factorial. And that is 5 factorial upon 2 factorial into 3 factorial, right? Now 5 factorial, you can write it as 5 into 4 into 3 into 2 into 1. That is same as 3 factorial, right? Upon 2 factorial into 3 factorial. So this 3 factorial will get cancelled with this 3 factorial and you will be left with 5 into 4 upon 2. And this 2 and this 4 will give you 10. So in how many ways you can select 2 captains from a team of 5 players? In 10 ways. That is the answer. So that is how you have to solve these problems. These problems are pretty simple. So let's see next one. So next one is, there are 10 students in a class. Okay. In a class, you have total 10 students. And a teacher wants to form a group of 4 students for a project. How many ways? So you can see how many ways can the teacher select the group. So basically, from 10 students, teacher wants to group or select a group of 4 students. Solution. So 10 students, you have total 10 students, need to select a group of 4. So basically, N is 10, R is 4. So how many ways can the teacher select the group? So in how many ways? Yes. So let's say there are students means S1, S2, S3, S4, S10 students are there. So a teacher can take S1, S2, S3 and S4 or any 4 students, right? Because there is no condition other than means out of 10 students, you just have to pick 4 students. So there is no other condition. So how many ways? So number of ways is equal to 10C4. And you already know the formula. N is 10. So factorial 10 upon R is 4. Factorial 4 into 10 minus 4 factorial. So that will give you 10 factorial upon 4 factorial into 6 factorial, right? Here you can see that 6 is bigger than 4. So you have to split your 10 factorial into certain product of certain number into 6 factorial. You can easily write your 10 factorial as 10 into 9, 10 into 9 into 8 into 7 into 6, 5, 4, 2, 1, right? And that is same as 6 factorial. Is that fine? Now, divided by 4 factorial into 6 factorial. But this 6 factorial is sitting in the denominator as well as in the numerator. So, this will get cancelled and you will be left with 10 into 9 into 8 into 7 upon 4 factorial means 4 into 3 into 2 into 1. Now you can see that 4 and 8 will give you 2 and 2 will get cancelled with this 2. And here you have 3 and here you have 9. So 3 and 9 will give you 3. So final answer would be 10 into 3 into 7. So that will give you 210. So these many ways a teacher can select a group of 4 students out of 10 students. Okay. Next problem. A box contains 8 different chocolates. Okay. You want to pick 3 chocolates randomly. How many ways? So whenever you see this, how many ways, that means you need to apply combination. How many ways you can do this? So again, you have total number of chocolates are 8. You need to pick 3. So number of ways is equal to 8C3. And now you just have to apply the formula. It is factorial 8 upon factorial 3 into 8 minus 3 factorial. And that is equal to factorial 8 upon factorial 3 into 8 minus 3 is 5 factorial. Now you can see that 3 and 5 is bigger than 3. So you have to split your 8 factorial into product of certain numbers into factorial 5. That you can easily do by 8 into 7 into 6 into 5, 4, 3, 2, 1. So that is nothing but 5 factorial divided by 3 factorial into 5 factorial. Same rule. Again, you can see that 5 factorial is sitting in the numerator as well as in the denominator. You can easily cancel them out and you will be left with 8 into 7 into 6 upon 3 factorial. But 3 factorial is nothing but 3 into 2 into 1. That is 3 into 2 into 1 is 6. So this thing and this thing are the same. So final answer would be 8 into 7. That will give you 56. Is that fine? So in how many ways you can pick 3 chocolates out of 8 is in 56 ways. Simple. Next problem. In a cricket team of 11 players, the coach wants to select 3 bowlers. How many different ways can this be done? So again, same solution. So in a team of 11 players, any 3 players you can pick because there is no other condition. They are not saying that out of 11 players, you have 5 bowlers and 5 bowlers and 6 batsmen. Such kind of conditions is not given. So what they want to know is out of 11 players, in how many ways one can select 3 bowlers. Simple. So N is 11, R is 3. Basically, you want to select 3 out of 11, right? So you know that. How to do it. Number of ways of selecting 3 bowlers out of 11 players is 11C3. Now you just have to apply the formula for NCR. That is 11 factorial upon R factorial into 11 minus R factorial. And that will equal to 11 factorial upon 3 factorial into 11 minus 3 becomes 8 factorial, right? So now again you can see that in the denominator 8 is bigger than 3. So split your 11 factorial into product of certain number into factorial 8. So factorial 11 you can write it as 11 into 10 into 9 into 8, 7, 6, 5, 4, 3, 2, 1. But that is nothing but factorial 8, right? Divided by 3 factorial into 8 factorial. 8 factorial will get cancelled with 8 factorial, right? And you will be left with 11 into 10 into 9 upon 3 into 2 into 1. So here you can see that 3, this 9 will get cancelled with 3 and you will have 2. 10 will get cancelled with 2, you will have 5. So final answer will be 11 into 5 into 3. And that is equal to 55 into 3. And that is equal to 165. So picking 3 bowlers out of a team of 11 players, you have these many ways. So you can select 3 bowlers out of 11 players in 165 ways. Huge number, right? Next problem. A deck of cards has 52 cards. You know that. A standard deck of cards has 52 cards. How many ways can you select 5 cards for a poker hand? So, again, simple problem, solution. So, you need to select 5 cards out of 52. So, in this case, you have n is equal to 52. Sorry, and you want to select 5 cards, only 5 cards. So R is equal to 5. How many ways? So number of ways you can do this is NCR, that is 52C5. This you can easily compute. So 52 factorial upon R factorial into 52 n minus R factorial, 52 minus 5 factorial, and that will equal to 52 factorial upon 5 factorial into 52 minus 5 is 47 factorial, right? So now you can easily see that 47 is bigger than 5, and if you want to expand it, if you go into expanding it, it will take a lot of time. So it is better you split your numerator into product of certain number into this. So you can write this 52 factorial as 52 into 51 into 50 into 49 into 48 into 47 factorial. So you can see that 1, 2, 3, 4, 5. So whatever is R, that many number will be over here. That you will get to know when you practice certain problems. So 5 factorial upon into 47 factorial. And you can easily see that 47 is sitting in the denominator as well as in the numerator. You can cancel them out and you will be left with 52 into 51 into 50 into 49 divided by 5 factorial. 5 factorial means 5 into 4 into 3 into 2 into 1, right? This 5 and this 50 will give you 10, right? And this 2 and 10 will give you 5. This you can easily use your calculator and do this calculation. So you will be left with 52 into 51 into 5 into 49 divided by 4 into 3. And 3 say you can cancel this 51 in 1 and 17. So 17. So this you can calculate, you will have the answer. So that many ways you can select 5 cards out of 52 cards. Let's see next problem. A school committee of 7 members. Okay. School committee of 7 members want to choose a president and vice president. Now the question is, does the order matter in this case? So now the question is not in how many ways you can pick president and vice president. They want to know whether, so here you can see that president and vice president. So basically you want to choose 2 members from a committee of 7 members. But now the question is selecting member 1, comma, member 2 as one group is same as selecting member 2, comma, member 1. Just think about it. What does it mean? Member 1, member 2. So you need to select president and vice president. So if you are selecting member 1 and member 2 as one combination, this is one combination. That means member 1 is president, member 2 is vice president. But if you are taking member 2 first and member 1 second, that means member 2 is you are selecting as president and member 1 you are selecting as vice president. So in this case, order matters. Is that clear? So in this case, actually order matter. So whenever order is important, you cannot use combination. Means NCR will not work. So in this case, NCR will not work because if you remember, initially itself it was written that combination is when order does not matter. So a combination is a way of selecting objects from a group where the order does not matter. But as you can see in the last question, they want to pick president and vice president. So in that case, order matters. So you cannot apply combination in this case. So here are some practice problems for you. So first thing is, as we have already solved many problems, you have to calculate 6C2. Next problem is find the basically you need to calculate, you need to calculate 6C2. 6C2 is nothing but factorial 6 upon factorial R 6 minus 2 factorial. Next, find the number of ways to select 4 students from a group of 8. So you need to select 4 students from a group of 8. What does it mean? You need to calculate, you need to calculate 8C4, right? 8C4 you need to calculate. A fruit basket contains 5 different fruits. How many ways can you select 3 fruits? So out of 5 different fruits, you need to select only 3 fruits. Now you can figure out what exactly you have to calculate. Means number of ways will equal to what? Next, find 10C7. Again, we have solved many problems based on this, so I hope you can easily do this. A teacher has 12 books and wants to pick 5 books to take home. So basically, out of 12 books, a teacher wants to pick 5 books. No order, nothing is mentioned. Which subject books she or he wants to take. So plain simple combination. Next problem is a school cricket team consists of 15 players. The captain needs to select 3 players for a special training session. How many ways can this be done? Again, nothing is mentioned. Nothing is mentioned other than you have total 15 players and captain wants to pick 3 players. So it is NCR where N is 15, right? N is 15 and R is 3. Next problem. A student council has 9 members and a subcommittee of 4 members needs to be formed. So out of 9 members, you already have a council of 9 members. You need to select a subcommittee of 4 members. Now, in how many ways you can do it? So you have N is equal to 9, R is equal to 4. So NC, 9C, 4 ways. We have already done similar kind of problem. A box has 10 different chocolates. How many ways can you pick 4 chocolates? Next question. A company wants to form a hiring panel by selecting 3 interviewer from 7 senior employees. So in how many ways can this selection be made? So you have 7 senior employees, right? And out of these 7 senior employees, you need to select 3 interviewer. So you know how to do it. A lottery has 20 participants and 20 participants and 2 winner will be selected randomly. How many ways you can winner can be chosen. So in how many ways you can choose your winner? It is again total 20 participant. In 20 participant, any two can be your winners. So n is 20, r is 2. You know that how to do it. So yeah, that's all. So we will do some intermediate level of questions in the next video. Yeah, that's all.